Hello there. Okay, so before I start, I just want to kind of tell you a little story. Yes, I work for Material ConneXion. I have a background in material science. I want to tell you a story about giving a presentation. So basically, it kind of brought me back down to ground, okay? So NASA asked me to give a presentation. So great, I'm super excited about this. Go down to Kennedy Space Center. Super excited, I feel like really, it's a prestigious place. So it sounds like it's going to be a great idea. So we go down to the Kennedy Space Center, and I'm assuming that I'm going to be presenting to a whole bunch of scientists and engineers. It's going to, auditorium of people like-minded. What I didn't realize was that I'm actually part of the theme park. So my presentation is part of the theme park's events. And rather than being in an auditorium beautiful like this, we're actually outdoors in the Florida sun on bleachers. So, okay, so I get ready to present. There's a person in front who's speaking in front of me, and there's a woman who's been into space. So this woman's been into space, so it's a huge crowd. There's probably like 50 or 60 people there, all on the bleachers, all excited to hear about the woman who went into space. So she gives a great presentation. She's got images of rockets. It's a great view. And then at the end, everyone wants to have her photographs taken with her. So they go down to the front. They get the photographs taken. I thought, oh, well, this is great, because they'll just want to stay for me. That was wrong. So after they've had the photographs taken, everybody leaves. So I get to stand up. So I stand up and there's a whole bunch of bleachers in front of me. And there's one guy left. And he's in the corner, and he's having his lunch. And he's sitting here. He's eating his lunch. He looks at me, he's like, oh, no, I shouldn't be here. He basically leaves. So I'm basically standing there, and there's a whole bunch of bleachers, and nobody is there. So I kind of gave up. So basically, that was probably my worst presentation ever. I tried to present to nobody, but yes. But it was a good event. The one good thing that came out of it was that because they're feeling so bad about the fact that I had to present to nobody, they actually gave me a tour of Tesla's SpaceX launch facility. So I get to see all like the actual space station area. So that was a great consolation. So anyway, that's my initial story. I'm here really to talk to you about materials, and the title is A Materials Future, because for me, what's interesting is what are the materials we're going to be using next? My background is in material science, but I've been working for the last 20 years with designers, with creatives, to help them find more innovative, more sustainable materials. So in this presentation, about 40 minutes, I'm going to go through 5 different topics. I'm going to introduce myself, partially, and also my library, but then also go through a range of different topics. Now, these may not make a lot of sense to you initially, but they will make sense as we go through. Digital gets softer, the end of the artisan's guiding hand, which is sort of a section on robotics. The evolution of natural, specifically leather. Then the resurgence of surface. How do we sort of think about the way that material surfaces have changed? And then my 5th one is kind of like a call to action. It's called A Materials Future. So I'm here as a material scientist, but someone who's actually worked in a range of different industries. And we can see here the range of different industries we deal with. And the reason why that gives us some insight, some value, is because we look at the industries that you're not typically looking at, and we wonder whether it's possible to take an innovation, let's say from automotive, or from cosmetics packaging, or maybe from fashion. How do we then adapt that to your industry? How do we then take that material, that technology, that process, and allow you to then use that material? So if you're interested, let's say, in the latest concept car interiors, we can show you those materials and potentially have those materials then used in your next project. So that's our advantage, our insight, is that cross-pollination. We don't just work in your industry, we work in a range of different ones, so therefore have insight from across the range of different design focuses. We have a library, and I'll talk a little bit about the library you now have in High Point. You have one of these now in High Point. I'll talk a little bit about that at the end as part of the Materials Future. The idea is, basically, we want to provide access to thousands of different material samples of innovative and sustainable materials, and then who makes them? So if you want to use them in a project, we provide direct contact information and as a conduit directly through to those manufacturers. How do you then use those materials? So that's our job, basically, helping you as creatives and designers and manufacturers. How do we help you create better products and do that through innovative and sustainable materials? Okay. So in the introduction, I'm going to need a show of hands first, okay? Who recognizes this phone? Okay, when did it come out? Anyone got an idea? It was 2003, so 15 years ago. This was the world's most popular phone, 230 million of them produced. Okay, now it looks kind of hokey, right? Okay, so now everyone now has a phone. Okay, so I want another question. Who has an iPhone watch or some sort of smartwatch? Okay, fair for you. How many of you think that you'll still be wearing that smartwatch in 15 years' time? Okay. How many of you think you'll actually be using your phone in 15 years' time? Okay, we got one. Okay, so you're kind of with me, and basically the transition of technology and materials in these sorts of areas tend to be relatively quick. And why I want to explain that to you is because what's fascinating to me about interiors and furniture is that just no matter what happens in the rest of the world, we still want to experience great interiors and great furniture. Though you can have a phone or a smartwatch that will basically go from non-existing to the most prized possession you have and the thing you will never leave the house or anywhere without, to a point potentially in 15 years' time where you never use it again. And I want to give the example, of this, which is a heads-up display. I'm predicting, or there are plenty of technologies that are predicting that at the moment, the reason that you use your phone because it's the only interaction you have with all of your friends, all of your data, etc. But with heads-up displays and also with things like Google Glass, and most recently Magic Leap's introduction of the augmented reality headset, it's quite possible you will no longer be using this thing and will no longer be the most touch surface that you have. Because think about it, the most touch surface you have is basically a piece of glass. So we're trying to think about ways in which our interiors can then interiors have been affected by the digital revolution. We're always wondering, okay, well, do I need to produce a product that has some sort of technology in it? And my thought is, you could do, and we've certainly seen that happen in fashion and sportswear. But let's think about 15 years from now, when you're probably going to be sitting in the same couch that you bought 15 years ago. Chances are, whatever technology was in it is potentially is obsolete. So I'm interested in sort of understanding the digital technology. How do we actually use it? But then also, how do we then choose materials that perhaps have greater longevity and greater value than just the initial idea of, oh, I want to put the Internet of Things into my product. I want to make sure that I've got a touch-sensitive surface in my product. So the example is that basically digital invades and gets everywhere, but then it recedes, it goes away. And that's my idea, and we've seen that with certain products that are trying to move away from something that looks heavy and metal or plastic or glass, moving towards something which is a lot softer and a lot more like our lifestyle products. Obviously, the Microsoft Surface. Then we also had things such as Levi's trucker jacket, where there's an interest in basically putting interactivity into fabrics. We also have the development by Google most recently, where it's basically trying to create, again, products that are more integrated into regular materials, our fabrics, our softer surfaces. That, to me, is interesting, because what it's saying is that they're trying to take away the idea of technology from front and center, because they understand at some point, I'm not going to need a screen anymore. I know that sounds crazy to us who have been basically brought up with computer screens and phone screens, but there'll be a point at which screens will no longer be necessary, because you either talk to the product, whether it's in the Google Home, something like that, or whether you've got a head-up display or you've got glasses. So the idea is, although we've started to understand that digital technology is going to be all the way around us, it is not going to be so obvious. And the idea is it's going to recede back into the background. So the idea, again, the resurgence of natural surfaces will happen. So rather than having to interact with a clearly technologically based screen, something cold and glass and hard, the idea is that we can interact in a more natural way, touching regular surfaces, talking, using gestures. We already have technologies that enable us to do this. This is a good example of basically capacitive surfaces or touch-sensitive surfaces that are made out of leather. So it's a leather surface that could be your couch and has all the interactivity that your phone does. In the same way that you can scroll and move things like that, this surface has the same sort of idea. The idea that basically I can interact with it without necessarily needing to interact with something which is hard and cold. We've also seen it move into things such as pieces of wood and basically more natural materials. So we're seeing technology exist, but then potentially only be on when you need it. I think one of the most frustrating things I find when moving into a hotel room is, okay, you can have a beautifully designed hotel room. The furnishings, the whole experience is incredible. Then what happens? You've got a huge 50-inch TV plonked right in front of the bed. To me, that ruins any sort of understanding of the sort of serenity and beauty of a hotel room. How do you change that? Obviously, yes, if you want to watch TV, it's possible. But there are solutions now where you can basically, basic information and technology can be basically receded back into our more natural materials, our expected interior materials. We've also seen this in information. I don't know whether any of you experienced this, but it is possible now to put directional information in carpeting. So again, taking away the need for large signs for that digital interface and putting it into our natural services. This is just using LEDs. You can see here, so the idea is that if I need to go some particular direction, let's say I need the restroom. Maybe the idea is if I'm walking into a room. So again, removing the need for connection to technology, walk into a room, I need the restroom. Okay, so on the carpet, it starts lighting up to the right. I walk right, and basically it allows me to basically go all the way to the restroom without ever needing to interact with any other signage or something. So that, to me, is the way in which we're starting to see digital technology recede. So initially, it was front and center. Everybody wanted it right there in front of their face. But that's not necessarily the most conducive to enjoyment of a space. So therefore, we're going to start seeing technology be there when it's needed, but not necessarily always on, only when necessary. Okay. The second section is, okay, the end of the artisan's, the use of the artisan, or the guiding hand of the artisan. I want to talk to you about this because I think for some people it frightens them, and other people it's a great technological breakthrough, but there has been an evolution of the way in which we use digital technology to manufacture things. We see it in a range of different industries. Two industries that's not used an awful lot in is currently our interiors and furniture, and also what I'm wearing right now, which is clothing. But we are starting to see changes in those as well. We started to see the manufacture of large format pieces. This is actually from the University of Stuttgart, which is done completely by a robot. We're starting to find robots that can actually manipulate things that are beyond just a basic block, that have some flexibility. The ability of that robot to stitch, to put together, and then ultimately to construct large format pieces. We can also do that with things such as furniture manufacture. This is actually an interesting process called cellular fabrication, where they are using a printer to, in a way, in the same way that 3D printing happens, but rather than simply printing onto a flat surface, printing vertically. So you imagine if it starts at the bottom, I can simply just take the nozzle of the printer and print, and it solidifies as it goes up, so basically create things in 3 dimensions that go vertically rather than horizontally. So you can create 3-dimensional structures of this type simply by just programming it into a computer and having the robot do the rest. So we're starting to see constructions, large format 3-dimensional constructions being produced without any human hand use at all. Here you can see the same format created on a very large scale. Because of course, if you can produce something this size, there's no reason why you can't produce something much, much larger. So think about how that might be possible to create furniture. Of course, what it does, though, it takes away the artisan's hand. It creates a level of repeatability, but you also potentially lose a little bit of the real value of the product. So there will, I'm talking about the loss of the guiding hand of the artisan, but I feel as though there will always be space for handmade things. We've seen that. We understand that. But there is also the potential to start producing product entirely through robots. This was actually an example of how we've taken that to full building size. It's an Australian company that basically builds a house in about 24 hours with bricks. It takes the bricks from the back of a truck. So that thing right at the back is basically, it feeds bricks out of the back of a truck. It takes them and basically places them. It mortars them up, basically puts the cement on it, and then sticks them on. So in 24 hours, you can build a brick house. So again, we are starting to see this and understand that there is no real sort of going back from this. We are taking away the use of hands, and that can potentially be a very good thing, because obviously building construction is not a particularly, it's relatively safe, but also putting humans in the middle of that always causes challenges. So by removing the human, you can actually create things obviously much quicker. You can do it overnight. You can do it in the dark. You can do it in inhospitable locations. The idea is then it's able to be produced, come rain or shine, in the same sort of process, but without the necessary need of humans. And I think, to me, that is exciting, because ultimately, there are many, many processes that we don't really want to do as humans. Obviously, we don't particularly like driving. We don't particularly like the sort of construction. I'm sure people wouldn't necessarily want to have to build a building in the rain if they didn't have to. So I think there's the potential to remove an awful lot of the sort of production that isn't necessary, isn't desired by humans. We've seen it in shoes. So the Speed Factory in Germany is basically a way of producing sneakers entirely through robot use. So stitching, gluing, putting together, again, the idea is again, removing the human from that. And it's a fascinating factory. It's relatively quick. Obviously, there are certain points where humans are still needed, but it shows sort of that inexorable rise of using manufacturing production in a much more automated way. And also, this one was fascinating. I mentioned fabrics, clothing previously. So the way that I've manufactured this suit has not changed in, I don't know, 300, 400 years. There's somebody who goes and takes a fabric, cuts the fabric, and then sews it. Obviously, that's not sewn necessarily by hand. Parts of it are, but other parts are by machine. But ultimately, that is a labor-intensive process. And if you ever go to a factory over in, let's say, India or Pakistan or Thailand where they're manufacturing, it's a hugely labor-intensive process. This, through a simple change in the material, has been able to then potentially manufacture T-shirts, jeans, and even these sorts of coats entirely by robot. They do it simply by taking the fabric, which is typically flexible, and then making it stiff. They make it stiff by adding some sort of starch material, and that starch material makes it stiff enough that a robot can pick it up. As soon as a robot can pick it up and manipulate it, then it has the ability to basically put it into a sewing machine and construct. Okay. My next one is the evolution of naturals. Now, for me, and for many humans, we have spent the last, I don't know how many, 2 millennia, avoiding nature. Most of the time, nature tended to kill us through bacteria, viruses, dangerous animals. So we had spent an awful lot of time enclosing ourselves in houses, avoiding nature, because apart from on our terms, because nature tended to be dangerous. So most of the revolutionary processes in medicine have been basically a way of stopping nature doing what it wants to do, which tends to be to kill us. So the idea of nature as basically something you need to protect against, or at least put a barrier up against. That was standard. What we see now, though, that with the evolution of the synthetic world, we started to understand, okay, well, now we really do understand what nature can do and what it can't do, and we can control it much more effectively. So we've started to see, probably in the last 5, maybe 10 years, a strategic move away from just relying on synthetic materials, our plastics, our metals, our ceramics, into sort of investigating more in terms of naturals. What can they do? Obviously within safe boundaries, but what can they do for us? How can we work with nature to produce new things? I want to go through a set of leathers, because this is a great example of how the evolution of naturals has really created some change. Leather materials, we've been using them for hundreds of years. It's our standard go-to for a certain amount of durability and a certain aesthetic. We know leather works for us. But of course, there are people who are concerned about the killing of animals, the use of leather as a potentially non-sustainable process. It uses an awful lot of carbon dioxide, an awful lot of greenhouse gases. What do we have as alternatives? Yes, of course, we can use our polyurethanes and our PVCs and those sorts of materials, but they don't really give us much back. It's always trying to make it look like natural. Here is a range of different solutions which actually takes nature and uses sort of the natural aspects and then creates leather alternatives from that. This was a simple one, which is simply dyeing and pigmenting of leather using just olive leaves. We've also got this one, which is using pineapples. So using pineapples as a raw material to create leather. The pineapple fibers and also the pineapple juice and the paste, you can actually create leather-type materials from that. Create accessories, you can create upholstery, all from this material using 0 animals at all. Same thing with this one. This is actually an Italian guy who was trying to make glue out of apples. He had a whole bunch of apples. He had a number of orchards, way too many apples. He couldn't eat enough of them, so he said, okay, what am I going to do with the apples? He started to try and make glue. He failed at the glue, but he ended up with a paste that was so durable. He ended up spreading it onto fabrics and now has a product called Frumat, which is actually a durable leather alternative made from apples. So in that simple thing, I think it's fascinating to understand how unexpected sort of solutions come from our regular materials. He didn't go to a lab. He didn't basically cook it up in some sort of genetic process. He simply was just playing around with apple as a paste. So once it's reduced down to its stickiness, they can actually produce durable coatings from that material. So what that suggests is there's an awful lot of new and undiscovered solutions from nature that we have yet to experience. I think that's probably one of the most exciting things about being a material scientist, is that material scientists and chemists for the last, let's say, 50, 100 years have been asked to present or create materials that solved our problems, okay? So they produced cheap and easily accessible plastics. Okay? So since the 50s, we've been using a whole bunch of plastics, and they work everywhere, because that's what we asked them to do. We said we want moldable things. We want them to be bright-colored. We want them to be durable enough. We basically want them to be inexpensive and easy to produce. So they did that. Okay? So we got a whole bunch of plastics. Now, unfortunately, we're realizing the plastics weren't such a good idea. But the good thing is, you ask those same scientists, well, okay, we don't like plastics anymore. Let's try and make something else. Let's try and make a material that doesn't contain plastic, that can potentially biodegrade, potentially comes from an apple source, that sort of thing, and they can do that too. It's just because we haven't asked them. So I'm optimistic about the next generation of materials that come out, because, yes, we understand there are limitations with plastics. We've understood that we don't particularly like the garbage patch that's in the ocean. But if you ask those same scientists to come up with alternatives using natural materials, they can do it. So at least now we're starting to ask them. So there's that potential now to come up with these solutions. So the apple leather is one good example. This one's another one, leather made out of mushrooms. Now, you think of mushrooms as relatively friable and they break easily, but you can basically synthesize them down into a highly durable material. Has the same sort of look and feel as leather, but coming basically from a fungal source. Also, there are alternative ways, alternative processes. This is actually a way in which a scientist has managed to find a way of gluing together cotton or other natural fibers. If you don't know, the difference between your polyester and your cotton is simply that the polyester is extruded like toothpaste and then woven or knitted into your fabric. Cotton, you have to spin. The process basically, they're little cotton fibers they get from the fields, and they spin them. This process enables you to create cotton in the same way that you do polyester. So as a result, you can create completely different textures that have the same sort of durability, same sort of washability, and same sort of stretch as, say, a lycra and spandex mix. Use them in yoga pants, but also you can use that same process to create a leather-type material. Again, it's asking a scientist to come up with an alternative to leather using cotton, or in this case, just natural fibers. It's possible to do it. So expect over the next 5 years to see a range of different types of materials that are coming from natural sources that can mimic, or are as good as, or potentially even better than your current materials, whether they are from a leather source, whether they come from a plastic source, because now people have asked the scientists to do this, and there is a market for it, because people are out there asking for alternatives to their existing materials. This last one is actually called Zoa from Modern Meadow. This one's actually a little bit more sort of high-tech. They're doing it through gene splicing or changing of genes, but again, the same idea. They're creating a leather material in a lab, but from entirely plant-based sources that are simply playing around with in terms of the DNA. So again, scientists solving problems because they've been asked to. Okay, so my fourth section is called Resurgence to the Surface. This is because, I think in the materials that we touch and feel and experience, I think once the digital revolution happened, there were a range of sort of different ways in which materials or natural materials and materials on our surface were sort of receding. We were finding that we spent most of our times looking at our screens and perhaps less at the surroundings. If you ever go into a coffee shop, if you ever go into any place where people are sitting down, they are not looking at anything else. You do it yourself. Basically, you sit there and you do that, and you look at that. But I think, as we start to see the move away from that digital screen, whether it is through augmented reality, whether it's through heads-up, whether it's simply through more voice and gesture recognition, there is going to be a resurgence of looking around at basically the surfaces and wanting to interact with those surfaces. So to me, it's a fascinating point in our lives where up until now, for probably the last 10 years, we've been focused entirely on a glass screen that shines at us. I think there is now a potential to go back to experiencing the world around us, and therefore the types of materials we use for surfaces will matter even more. Just some examples. We have the ability now, of course, to make super, super soft surfaces that are also very stain and water resistant. This is an example of a high-performance cashmere. Nothing sticks to it. So again, the soft feel of a cashmere, and yet you don't have to worry about stain. The ability to make plastics look and feel like anything. We have seen the ability to mold in all sorts of different surfaces. Yes, of course, you're touching a plastic, but the ability for that to just feel a little different, a little more interesting than your standard molded piece. Also to mimic as well. So the material on the left-hand side is actually a molded leather. On the right, it's basically a replica in metal. So the idea of mimicking other surfaces, so taking an existing natural surface, whether it's some sort of leather, and with a texture, and then mimicking that onto a metal or other material. We've seen an awful lot of play with different textures on those surfaces, the ability to take a sort of much more natural or sort of organic-looking color and effect. This one's in silicone. This other one's in a polyester. The idea of sort of creating unique looks and effects through, again, a molded piece. But the idea is that you want to sort of create a surface which is the material which has that sort of color and effect all the way through. Rather than simply being a coating and an inauthentic surface, here you've actually got a material which has that effect all the way through. Seen obviously the ability to remove complete stone surfaces and put them on walls. So to recreate a stone surface on a relatively thin and flexible material. So you get that look and feel of a real stone, but actually through a flexible and a surface that's relatively light and easy to put up. We've also seen solid surfacing, moving away from just a completely hard and, I guess, sterile surface into things that look a little bit more like lava stone, a little bit more like a stone you might find in nature. And this was a good example because it's the idea of also taking surfaces and having them evolve over time. Many of our clients are always looking for materials that can somehow grow with the user, can change in some way. So how do you do that? Obviously, you can have things which patina and rust. This is a great example because the company itself just goes to all of the different key locksmiths around London, picks up all the waste material that's from the cutting of the keys, takes that and puts them into a solid surfacing material, and the waste itself tends to age and patina over time. So the material might not start initially on what looks like on the right-hand side, and eventually patina to what looks like on the left-hand side. So it's an ideal and sort of like a surface which perhaps grows on ages or evolves into a completely different look over time. Sometimes the surface can be a way of showing sort of the environment around us. This is actually an artist who's creating a product that starts off as a very, very white surface. So there's a certain technology called the photocatalytic effect, which is a way of creating on a surface something which resists dirt. Okay? So what this artist does is she paints this dirt-resistant coating onto the surface, onto certain patterns on the surface, and then leaves the tiles outside in Milan. And over time, what happens is the dirt starts piling up on the bits that aren't protected. So those are actually the dirt and soot from Milan that's basically picked up. So whatever city it's in, your tile will originally start off as a completely white surface, but then over time it'll pick up dirt, but in a specific pattern. So rather than just being generally soot-covered from an area, it actually creates a kind of beautiful pattern, showing sort of an evolution of the way in which the city is basically creating dirt on the surface. My last one within this is a fascinating one. It's a material that's quite hard to understand or believe. It's something called Vantablack. Sometimes the surface you have, you don't want it to look like anything at all. Now, Vantablack is the blackest material that we've ever produced. It's almost as black as a black hole. Not quite, but almost there. So the image on the left is basically a sculpture, I think, of some eminent scientist. And the image on the right is that same thing, but covered in the Vantablack. There's no special lighting. Basically, it removes all color, all light. So basically, you see nothing at all. So no matter how convoluted that surface is, it offers a black surface. It does this through using carbon nanotubes, which are basically on the surface and absorb all kinds of light. So the idea is I can take any surface, whether it's the ceiling up here, whether it's the floor, any sort of surface, and remove all texture, all color, all light. That's fascinating for people because what it does is it removes any texture. It removes, and basically anything you look at, no matter what the surface of the building looks like, when you look at it in regular daylight, it will basically look like there's nothing there at all. It's fascinating sort of for interiors. It was actually used on the outside of a building in Korea, but the idea is that it can remove all texture and then give you a completely blank surface. You wonder, well, how would I use that? And I was working with a footwear company, and they said, well, that'll be great for us, because what we can do is we can simply just put a sneaker right in front of that completely black surface, and then all you ever see is the sneaker. You can light the heck out of the sneaker, and there's nothing behind it, because basically the Vantablack behind you just removes all other color. Okay, so I've gone through a range of different materials and technologies, but the whole idea for this, and what I want to say about a material's future, is that there's a whole bunch of things evolving, whether it is through natural materials. Obviously, I showed you the evolution of leather. Whether it is the way in which digital technology is affecting our interiors and our products. But how do you find out about those things? How does one sort of learn and understand? Obviously, we do that, and that's our job, is to basically educate and provide insight. And as Tom mentioned earlier, we do actually have a location now here in High Point. It's at Plant 7, which I think is 410 West English Road. It's a location, it's a beautiful, beautiful factory. It's 4 floors, it's an old industrial space, and we've provided a Material ConneXion library there. The resource is available year-round. So as a library to come and research, we will have a full-time researcher who can spend time with you there. So the idea is to bring that ability to find these new materials, to learn about them at that location. So here, this is actually an image that was taken yesterday. The library itself is up and running. I encourage you to go visit it. It's stop 27 on the red line. The idea being that we can now show you the sorts of technologies and materials that we have in our database, but here actually in High Point. It's a simple process. There are material samples that you can access, and also contact information will allow you to then find out who manufactures the material. So it's a hands-on experience with a material researcher who can then guide you through that process of trying to discover new materials and understand a little bit more where they came from and potentially then how to use them. So that, to me, is the material future that we have developed and also that we've now wanted to bring to High Point. So thank you very much.